friction කරා නේද පුතේ? මට නිකන් last note එකේ පොඩි photograph එකක් දාන්න අන්තිම පිටු. අන්තිමට කරේ කොතනද කියලා මට මතක නැහැ. දාන්න පුළුවන්ද? අන්තිමට අපිට මාර වැස්සක් තාම වහින. ඔයාලටත් ඔය තාම වහිනවද? මේ තාම වහිනවා අපිට. loss of friction වෙන්නේ නැවැද්ද? යන්නේ ඉක්මනට. All right. I think we stop at the loss of friction. හරි නේද මම? ඔව් කියන්නේ.
Yes, sir.
Right. That's why we want, right? Because the small things regarding friction also we need to do today, right? We have to calculation how we can solve the question related to friction, and then the next one is that's equilibrium of forces. So I'll try to finish this all the things covered. We will pass now, right? Because if you can, we can do some additional plan. Also, we will try to finish the syllabus rapidly. I think it's better for you because then you can do revision and you can do more papers and we can discuss the more papers and then it's better for you because most of the students they want to teach just during last 6 months just before the exam. So then if we can complete our theory parts and other things better before the 6 months of the exam, then I think it's benefit you to understand everything in the last 6 months. So then we go through the theories rapidly, quickly, and then try to cover these all rapidly, right? So that's your help. Need me to cover those. ඔයාලට පුළුවන් නම් බලලා අපි ඒ වගේ මේ ටිකක් කරමු. Additionally පුළුවන් නම් දවස් 2-3ක් හරි කමන්නේ if you want it. මොකද මට ඕනේ නම් online එක දවසක ආරම්භ කරන්න පුළුවන් issue එකක් නෑ. හරි. There's no any additional charges for the classes, but I will do with the same price because the physical class is doing on Sunday, and then we can do another class on as online. Then we can cover this syllabus because your school is also going much faster. So that's why I'm asking you that there's a term test. You can answer the questions. We cover this all. ඔයාලා මොකද හිතන්නේ? එහෙම කරමුද එක දවසක් යන හැමදාම නෙමෙයි ඉතින් පුළුවන් වෙලාවට online දවසකුත් කරලා theories ටික ඉක්මනට cover කරගන්න try එකක් දෙමු. ඔයාලා බලලා කියන්නකෝ හරි. ඔයාලට කැමති නම් විතරක් එහෙම කරමු. නැත්නම් ඉතින් සාමාන්‍ය විදිහට laws of friction කතා කරා. ඒකට මම ඔයගලන්ට එදා මේ ඩිස්කස් කරා නේද තව this limiting friction, static friction and kinetic friction කියන්නේ මොකක්ද කියලා කිව්වා නේද? ඒක කිව්වනේ ඒ ටිකක් කිව්වා. හරි. පරි question එකක් ඔය ටිකට කරලා ඉවර වෙලා ඊට පස්සේ අපි අතන දැන් කිව්වේ දැන් coefficient of kinetic friction and coefficient of limiting friction කියද එක limiting or we can call it a static friction also, right? There are two type of friction coefficients, right? If that's like in a question they are not mentioned that what is the friction as the kinetic or limiting, then you can take it as the limiting and kinetic friction are equal. The same frictional coefficient you can use for both. If they are not mentioned that, right? If there is two different values, so then they will mention it clearly. You can keep in mind. Then on keep put a star right there. It's a better. You will young body strike. If you can write there, right? That the if the kinetic friction and the limiting friction is kinetic friction and limiting friction. Kinetic friction and limiting friction are not clearly mentioned in a question. Are not clearly mentioned in a question. Are not clearly mentioned in a question. Can be taken as the coefficient of static friction and kinetic friction are equal. Coefficient of static friction and kinetic friction are equal. So mu s equals mu k. So no, sometimes they use the mu s or mu l or mu. And the kinetic friction they mentioned as mu k or mu d. The dynamic friction we can say the dynamic or kinetic, both are same, right? Right. Then that's now an example. Question. That's a block of mass that's 5 kilograms that's placed on a horizontal table and a force capital P is applied horizontally on the constant force capital P, right? But then you know that we have some friction applied on the body because it is a rough surface. The rough surface and the dynamic and kinetic, so static and dynamic friction for the contact surfaces are that's mu s is equals to 0.4 here and mu k is the 0.368. The mu s means that is the limiting one, right? Because that's the maximum value of the static friction is the limiting friction. Because only the limiting case you can apply the F equal mu r for the stationary bodies. While it's moving, you can apply it as a mu k. Just you need to clearly distinguish these two frictional cases, right? In the case of static case, you cannot apply this mu r because if, in that case we know that the external force applied on it is equal to the frictional force. Last day we discussed, right? Question a block of mass 5 kilogram is placed. A block of mass 5 kilogram is placed. A block of mass 5 kilogram is placed on a horizontal table. On a horizontal rough table, the hot structure of rough chamber. Right. Right. The static and dynamic frictional coefficient. The coefficient of static and dynamic friction. The coefficient of static and dynamic friction. Coefficient of static and dynamic friction are 0.4 and 0.36 respectively. Are 0.4 and 0.36 respectively. Actually, it's not to be given as a, because the larger value is the limiting, that's the static part, and smaller value is the final. Respectively, right? Static dynamic friction 0.4 and 0.36 inside respectively. Right? Right. A force, an external force, an external horizontal force by P, an external horizontal force, capital P, your P, P is applied, here P is applied on a body, on the body as shown, on the body as shown. Find the acceleration of the body and the frictional force. Find the acceleration of the body and the frictional force on it. Frictional force on it. Frictional force on it. When then write that first part on number 1 when the P equals 10 Newton. And the second part when the P equals 20 Newton. And the third part when the P equals 30 Newton. There are 3 force values. You have to find that what is the frictional force and the acceleration in each cases. I will give some 5 minutes to try first. First you try to get answer, then I will guide you how to try. So the today's session I will share some more questions regarding this. Right. So you can ask the column. Let's see, first what you need to do. First you need to do, right? Don't go for those values of the p. First you can try. But if you, when it's moving like this, you can see the weight of the body is onward, that is 50 Newton. We are into 10. A normal reaction is also there. Which are there is no motion in the vertical direction. So then you can say that R equals that is 50 Newton. And then you can calculate the frictional force, that is Phi 10 limiting friction. Because the frictional coefficient is given, so you can calculate that the limiting friction. What is that mu L R? So that's mu L mg. Mu is 0.4 and R mg doesn't 50. So you can write it is 20. And then calculate the binding friction of the mu here. We can see it's also mu R is 50. This will be very 18. I calculate this, you can see that if the external force is greater than this limiting frictional force, then only you can move the body. If it is under the value, that's small than this value, limiting friction, it will not be moved, right? So because if you want to move it, you need to apply the force, external force should be greater than the frictional force, the limiting frictional force. Then now we can see, then when to the space, if the P equals 10 Newton, then the P is less than the limiting friction. So we can say that body is at rest now. It is at rest, not moving, stationary. So therefore, the frictional force acting on the body is static friction. So this is the frictional force. That Fs is equals to the external and applied force. I told you that last week there is no friction. Sorry, no sorry, the applied force is less than the limiting friction. Object is not moving, it means that frictional force equals to the applied force. So now the acceleration is zero because no motion. That's the first part. And the second part, if the P equals 20 Newton, now this P equals limiting friction. So then also body is just to move, but it's not moving. Still not moving, so the acceleration is zero. And in this case, the frictional force equals to the limiting friction, that is 20. And also it's equals to the limiting. And the third one equals 30 now is greater than the limiting. So the body is moving. It is moving. When a body is moving, the frictional force applied on the body is a kinetic friction. So the frictional force is in 18 Newton. It's a kinetic. This is the frictional force. For acceleration, you can use the equal ma towards the horizontal direction. The applied force is 30 now, and the opposition force is the frictional force. It is 18 Newton. The mass is 5 kg and acceleration is 8. If I simplify this, 12 divided by 5 is 24 meters per square. This is the acceleration. Okay, is it clear? Is it clear?
Yes, sir.
Okay. If there are any doubts, you can raise your hand or you can any signal to give me the signal because I cannot always see the screen. That's all. Right. It's better you can switch on the mic and ask anyone what because sometimes I can't see your messages in the screen and the board and the distance is there. Right? Small lines on the camera. Right. Maybe there are the frictional force have this kinetic friction applies when they are moving on it. Every friction is applied. That's when the object is just to move, and other way, on when the object is not moving. Or stationary cases, you have to know that the frictional force applied to the body is then this static. There is equals to the external force applied on each side. Then can I erase the board?
Right, sir.
Still right, you know. To finish the diagram, you raise your hand. Your hand I can use. So then I know that you finish the diagram. Then I read it. හරි. හරි නේද? හරි. මම දැන් දැක්කේ මැසේජ් එකක් අහනවා. රිපීට් කරන්න කියද්දි ප්‍රිපරේෂන් එකද? හරි නේද? මම හරි. එහෙම රිපීට් කරන්න ඕනේ තායි කියන්නේ. මම රිප්ලයි එකක් දුන්නේ නැත්නම් ඔය අහලා දාන මැසේජ් වලට මේ මයික් එකකින් කියන්නේ නැත්නම් මට තියෙන්නේ ඒක. හරි. Then I erase the board, right? හතරක්. finish නේද? ගයිඩ් හරිද?
Hari sir.
Then right angle of friction. Ready? The angle of friction, right angle of friction. This frictional coefficient we can find between all the angle of friction also, right? So let's see, we have the body like this. Purpose there. An over reaction with R. And you know that if there is any tendency that you apply the external force there and the frictional force acting on it opposite to the direction, then only this friction will apply, right? If not, the friction is not applied in that, right? And then weight of the body is downward, and we can say that the this R and this X, the resultant of this I will go parallel that's a start and start rectangle. So this is the resultant of this R and X. We call this a contact force. What will contact force is this? This is here. This F net. We can say this is the contact force. So it is the resultant of F and R. F means the friction, right? This is because draw the diagram like this, you can an idea. And then this angle here is that, right? So it is called the angle of friction. Right? It is called the angle of friction. Right there. The angle of friction is defined as the angle of friction is defined as angle of friction is defined as angle of friction is defined as the angle which the contact force makes, angle which contact force makes with the normal reaction. Contact force with the normal reaction. Friction is defined as the angle which contact force makes with normal reaction. Okay, then you can draw this, and then from figure you can see this is the tan theta that equals to the tan theta equals to this frictional force divided by this frictional force divided by this one. This tan theta frictional force is written by this, right? And the normal reaction divided by this tan theta equals this frictional force divided by R from the figure. We know there's the friction because as F equals mu R, right? Then we can tan theta equals, if you can substitute the mu R and then R cancel out. So it's tan theta then equals me. So the tan value of the friction, angle of friction is equal to the coefficient of friction. Find the angle of friction, that is important. If you know the angle, then by taking the tan value of that, you can give the coefficient of friction. Okay, copy down. හරි නේද? ඉතින් හරි. මොකද? මොකද? හරි. හරි. ඔය එකක් දෙනවා මෙහෙම දෙන්න. object එකක් මොකක් හරි plane එකක තියෙනවා. If you increase the angle or inclination, then at the point it tends to slide down. Right? It's not slide down initially. You can see it's like this. Then I'll show you how we do this. If I place, this is a plane laser in my phone, right? So this is the object. If I slide down, you can see it's sliding down by small angle because this surface must move. If I place the object in the other side, it's also smooth. That is slide down. But I'm taking rough place, which is you can see here. But increases, so it's now it starts sliding, right? So that angle which the body starts sliding, inclination angle, we call it the angle of repose. So that's also come because we can raise it up until the component of the weight is equal to the limited friction. That is the maximum value. And then it's sliding means that's the reduces because when the object is moving, the kinetic friction applied on it, it is less than the limiting value. So then it starts motion and it's moving. Can be accelerate or can be moving with the uniform speed. But when it start the motion, that's the once it start the motion, you don't need much larger force to apply on to make the motion constantly moving, right? So if you need a smaller value, that's a kinetic frictional force is much smaller than limiting friction. එකත් අපි ඔතන චුට්ටක් සඳහන් කරනවා නේ. එවැනි the angle of repose. Right. Repose. Angle of repose. Up under that, right? Yeah. Angle of repose, right? Right, yeah. The angle of repose is the angle of repose is the angle. Angle of repose is the angle that an inclined plane that an inclined plane of inclination inclined plane, so that an inclined plane makes with the horizontal inclined plane makes with the horizontal when a body placed on it is limiting equilibrium is in limiting equilibrium. They say what is the limiting equilibrium later. This is discussed up because it's related to friction. So the angle of repose is the angle that an inclined plane makes with the horizontal when a body placed on it is in limiting equilibrium. This is angle alpha. So at the angle alpha, let's say it's at the motion. So this is the limiting equilibrium. Equilibrium means that it's there are two ways we can the equilibrium can be changed. So because of sliding down and other one is rolling down. Okay. And then we when the block is when the block is just about to slide. Is just about to slide. I remember. I can draw this. I think that I use alpha. This angle of the cross section is G R. Or on to this side is going to be sine alpha. You know this one. And to this is alpha, right? This side is component of the weight to perpendicular to the line is B plus alpha. And the frictional force, that is limiting friction, the FL I use limiting value of the friction. Limiting part, right? And there's no motion, right? It's still no motion because it's just to slide. Then we can say the downward G sine alpha, that's equals to the FL. And then the perpendicular to the inclined, you can apply this process. You can say then R equals R, which is R equals the constant. This is first second, this is second one. If you divide this first one by the second one, this side is the right, this is mg cos alpha, and this sine alpha divided by mg cos alpha, it should be tan alpha, right? Then this will divide by R is equal to the mg multiplied with the tan alpha. No. The mark of number is the FL of R equals tan alpha. Clear? And in this case, this FL of R, FL equals to mu R also divided by R, that is tan alpha. And here R cancel, then it's also equal to mu equals tan alpha. Right? In this case, we can say this. So the tan value of the repose angle is also equal to the coefficient of friction. So then we can say this repose angle and the angle of friction are same. Right? So previously we discovered theta and this angle y is same thing, right? You slide a body on a plane, and then if you place the object on that plane, same plane, when it's the plane is horizontal, and this angle of the friction which equals to the same, and that's the same value of the angle, you can slide incline the plane, then you start the motion. Right? So it is important. If you know the angle of friction, that means that is the angle which you can incline the plane, which the object to make its motion. Clear? Right. So like I make equal the angle of repose and the angle of friction are equal for the same plane, right? Your different planes they have the friction elements different. If the same plane you incline, then the body start the motion at the angle alpha, let's say. So then that is the angle of friction between them when the object you place on the that same shape. Right? Let's now let's see that's how they update your pulling or pushing. Which one is easier? When you apply the same force on same direction, the direction means that's same angle. Then let's see which is easier, the pulling or pushing. You can write it as or we can write that. Actually, pulling is easier than the push. Right? You hold two objects to move from one place to another. If you pull it, it is much easier than you push it, right? Table like difficult, but yeah, it's much easier. So most of the cases we pulling the buttons. Right? Example, let's see in the doors. Someone the roll push and the pulling the door pulling is that easy. Then is push. Push karangane एक हमारा So let's see how this is because of the friction. Then you write down that pull is easier than push. So then we'll going to prove it, right? Then the pull is easier than push. Pull is easier than push. Under the right, consider a block of mass M, symbol M, a block of mass symbol M, placed on a rough horizontal surface, placed on a rough horizontal chamber, the surface, the surface. Then we push this one. Okay, then write the coefficient of the static friction between the block and surface. Coefficient of static friction between the block and the surface. The block and the surface is mu. Is mu, right? The coefficient of static friction between the block and surface is mu. Right, and consider a force capital F is applied at an angle theta with the hull surface. Consider let a force capital F, let a force capital F is applied at an angle theta with the horizontal. At an angle theta with the horizontal. Horizontal. And so then let's see this how much this force is required to initiate the motion. Right. From that, and then of course this is pulling it. We're pulling, it is pulling there. Okay. Applying the force. Now you push. Okay, by applying the same force with the same angle. This and this. The same force. Okay. So other forces also. Okay. Weight is mg. Reaction R. Then the friction applied on it's here also applied friction selection press plus same surface, right? The same normal reaction not normal reaction will change here because right, this is R1 and this is R. In this case, this R1 and R2 are not equal to weight. Let's see how it changes. This is FS1, right? This is F1 and F2 are used because the frictional force in these two cases are equal. That's why. You can see then how it's different. We are seeing the form because in this case, this force given a component is vertical. This one also because of that, this R changes. If there is no any other forces other than this normal reaction, then only it's equal to the weight. But if there is a force applied on the system that's in the vertical direction, then R will not equal to the weight. It will differ. Now I will study the component of this direction is cos theta, and in this stage is sin. And here the component is downward now. That is sin theta. Component of this direction of this motion will be here. we consider this upward R1 plus the H line beta is equals to the weight. You can say R1 equals G minus F1 from then apply this expression cos theta minus F1 protection equal to the let's say it becomes 0 because I'm considering this is just to start the motion, right? No acceleration. We consider this force required to just start the motion. That's 0 because no motion. So this equals to that if one inverse plus theta. We need to find this if force it, right? So then what you need to do, you can substitute this value. That is if you go mu r, so then you go r r1 cos theta and y and r1 you can taken from this value which is mg minus f sin theta. And this is multiplied by mu, and this also multiplied by mu. This is mu f sin theta. You can take this to this side, then taking this f out, we can write this times cos theta plus mu sin. Like about I can find mu m g. Right? So finally, you can write that is f then equal. I write it there. Because mu mg divided by cos theta plus mu sin. Is the and the applied force in this case is mu mg divided by cos theta plus mu sin. If these values you know, then only you can say that what is the force applied on the body to start the motion by pulling it. Is pull. Let's say in the same way you can calculate how much is if when you push it to start the motion, how much the force you need to apply on the body to push it. Right? Then you try to write the same way that with the different way, then it's here the F sin theta is upward, here F sin theta is down. Right? So then normal reaction will be changed. It's clear? Now you can write these equations similarly for this one and then find it. Then you can find that this F is different than this value. So it means you that one is greater than the other, you can see that. So that means if one is greater means, so you need to apply larger force to move the body. Then you can say that which one is easier. Clear? No, Ricky, if you have any doubts or anything you can understand, you can tell me. Jangan mau kerana kan tiga lian bahan mang kai lebih. Tiga lian mang. Okay. Wala ni war pasti kan. Ada betul. Okay. See. So what you will do now this sum, right? I'm not taking this sum, but we can change planning. So the answer or that remain there. And then it's not now the pushing. When it's push, you have to find the everybody I mean dot in the right is R2 here. It's R2. And then if sine theta is downward, it's minus thing, sine theta. And it's equals to mg, right? It's upward first, that's equals to downward. Then you can write it R3 first, mg plus epsilon. Here in the horizontally, that is the cos theta, that is minus projection of, so it is, let's say, 2 because of cos theta. Actually, mu r now this cos theta mu r2 is mg plus epsilon theta, so this will be the if this side is minus, right? So here you can see now it's positive equal to mu mg cos theta minus mu sine. Yeah, right. This is a push. It's 4 Now you can see the denominator is smaller here, then this is denominator is large. The numerator is same for both. So it means that larger the denominator, so it's smaller this value. So you can say the pulling force is less than pushing force. This is the force you regard to just move the body, right? So that means the pull is easier than push. Funny, can you pass me? I didn't come. It's clear? Anything देखा? Yeah, नहीं. मुकुट क्या नहीं right? And then write some example, right? Write example മെമ്മറിയാണ്. Then a block of mass 2 kilogram. A block of mass 2 kilogram. A block of mass 2 kilogram is placed on the floor. Is placed on the floor. Is placed on the floor. The coefficient of static friction is the coefficient of static friction is 0.4. Is 0.4. A force of 2.5 Newton. A force of 2.5 Newton. A force of 2.5 Newton is applied on the block. Is applied on a block. The force of 2.5 Newton is applied on the block as shown in the figure. As shown in the figure. Calculate the coefficient of friction between the block and the floor. Calculate coefficient of friction between the block and the floor. You can find this one. Compare the coefficient of friction, I mean force of friction. So coefficient is given. That way the force of friction. Force of friction. Between the block and the right. Force of friction. And second question is going that mean frictional force on 2 kilogram block. Block. The arrangement shown in Right. It's a 1 kilogram and this is 2 kilogram. Then mu is given as 0.1. Angle of inversion is final reaction cost of this one. Here this. Vamos a llegar ahí. Tomorrow, right? Tuesday. But like, then you can see here, and our next campus. After that, given the new F, then F3 was, you can see there's no motion. This way. Here, I mean, there is no motion. You can see that. It is, you have to check first. Let's say the integration is mu r. Mu is 0.2, r equal to mg. Then 0.4, mg is drop of mass, I think it's 2 kilogram. 2 kilogram in cube. Weight. 18. So this is a greater than this applied close to 2.5. When you apply 2.5 Newton load, then the object is not moved. So no motion. Therefore, the frictional force is equal to the applied force. That is 2.5. This is the friction force, right? And in this friction, where is this one? Here this tension and it needs to also when you calculate the weight component of weight is to continuing weight to this direction is weight is sin t sin 30 cost. So then R we can write that R is our reaction plus 70 first third. It is in the 20 first third is root 0 to the premium, and that's a limiting friction. If you find a limiting one, then you are as limiting one R. That's 8.5. 3 is about 20 and was 1 8.16. Sorry. Then you can find, let's see, this surface is smooth one. You can see here, then the weight from this side is 10 Newton. And then if it is smooth one, let's say this side 20 sin 30 is 20 sin 30. Sin 30 is half, then it is also 10 Newton. So the both sides they apply the same force. So then there's no motion. This situation, the object will not be moved. Right? So there is no any tendency to motion. So the frictional force is then zero. This maximum friction I find that to get an idea of that we are going on, but the tension is applied on there and it's the same force is applied to the downward. So then there is no any tendency to move. So there is no relative velocity between the two bodies, so there is no friction. So actually, when you calculate, you can calculate it like this. Right. You will write them. And in here you can write there. The friction, in this case, the friction is C. The friction force is C. Do I want to explain it right? Then let's see. And then suppose the plane is smooth. Then is now let's see it's no friction close the plane is smooth. So then the acceleration you can write that is the unbalanced force. Unbalanced force is like 25 30 minus x divided by total mass to b plus 1. So then it's zero. So this gives 0 because this 10 and this 10 is 0. Then write the system of two blocks in the system of two blocks are in equilibrium. There's no acceleration, right? Are in equilibrium. On a smooth inclined plane. On a smooth inclined plane. So it cannot be friction applied on it. Therefore, there's no friction because even in a smooth surface, if you place the two bodies, that will not produce any acceleration. So then we can say that any other rough surfaces also, it cannot make any motion. So then there's no tendency to move. So no friction. තේරුණා නේද? තේරුණා නේද? Hello. තේරුණාද පුතා?
Oh, sir.
Our question එකක් දෙන්න මේ වෙනස් එකක්. You listen, then we go to the equilibrium points. I'll share this question with you, right? I think you can see, you can write the question and then try to answer. Here is the given that we place the body on a horizontal inclined plane and then increase the inclination. Then they ask in the question how that inclination with frictional force apply on the block changes with this inclination. The same way you can do the calculation. I'll give you the 5 minutes for this one also. So then try to answer, right? So then I'll explain about. Okay. You can write the question and then try to answer. Other. Well. බලමු කොහොමද හදන්නේ කියලා. හරි. Logic, right? Triangle velocity. I can give you that based on the shape. And it is stationary, it's not moving initially, right? First part, this theta equals. That's question given that sine inverse 1/3, 1/3. And it means you that theta equals sine, sine theta equals 1/3. This is the theta. Angles are given like that. You take the sine and then the theta of the sine is equal to that's sine of theta is equal to 1/3, right? Okay, then weight is 15 into 5 kilogram. And here the 50 sine theta, the frictional force. Say 1. And here is frictional force. That's slow motion. You can see that the frictional force equals mg sine theta. The forces acting along the incline should be 0. The resultant should be 0 because no motion. So then mg is 50 and sine theta is 1. That is 50 divided by 3 is 16.66. In case now this inclination increase to sine inverse 3/5. It gives you that sine theta equals 3/5. If you draw the triangle like this, it is theta. Sine means that is the adjacent side divided by the hypotenuse. The opposite side divided by the hypotenuse. The adjacent side will be the slope. Using Pythagoras theorem, you can then find the cos theta also. Because we need a cos theta to calculate normal reaction. So here the normal reaction, let's see, R. And then the force along the direction of perpendicular to the inclined can be 50 cos theta. Then you can write as R equal 50 cos theta. Cos theta is 4/5. 50/4 divided by 5. Into 4 divided by 5, that is 4. And the frictional force is given with it slowly moves down. So slowly moves down means we can say that it's moving with constant speed. So if the side, the frictional force in this case also equals to the mg sine. Mg is 50 and sine is 3/5. So the frictional force is 10. 13. By solving this, we can write it 13. In this case, the friction, let's say example, it is how the frictional force equals to the weight, that's a component of the weight to the incline, and it is moving the constant speed. There's no acceleration. Now the coefficient of friction you can find. Kinetic friction you can find that the frictional force divided by the normal resistance. That's 30 divided by 4. That's 3/4. Or we can say it's at 0.75. Right? It asks you to go the ask you to find the acceleration. When it's theta equals sine inverse 4/5. How the sine theta equals 4 divided by 5. If the sine theta equals 4 divided by 5 means if the sine theta equals 3/5, cos theta is 4/5. If the sine theta is 4/5, then cos theta is 3/5. The same triangle you can draw, you can interchange these two ones. So in this case, cos theta equals 3 over. And when it is moving now it's moving the acceleration G. Now there's acceleration. So the normal reaction is equals to the mg cos theta because there is no any other forces acted perpendicular to the direction of the end, right? So the mg is 15 cos theta is 3 over 5 and I will be 13 in the force applied on the surface. And then find that you if people in me bound with it. Cos is 10 50 sin theta minus friction for let's take F3 equals to the mass into the acceleration. Now this friction force we can write mu r. So mu is 0.75, that is 3 over 4. R is now already fine, that is 30. So that order together is equals to the 22.5. Substitute this friction force to there, and sin theta is 4 over 5, and then mass is 5 kilograms, so you can find the acceleration. Okay, can I erase this part? Let me know. Maybe what I'm doing.
Padayna, sir.
Continue at the end of the again, my acceleration equally 30. Figure take one here. Here, I'm going to learn one here. Snack the entire account, the young and Ramana. Right. Then erase this part. Here the friction was more, then we need to find the acceleration. So substitute here 50 the sine 30 the sine 3 times 5 minus the frictional force to 20 mass is 5 and acceleration. And this is 40 minus 2275 for 5a. Then acceleration because this is 17.5 divided by 5 is 3.5. That's acceleration. And now let's see how we can draw this graph. Okay, here in this question, the first part to third part. When is that the first case, if the object is stationary. Second is when it start the motion. And third is when it is accelerated. If you remember this. And the it is stationary, that the P was in the sine theta, you can say, right? The sine theta. So that value will be at the 16.5. And if you increase the inclination, then this F increases because sine theta increases. Remember that the second question, second part, the frictional force will be third in. And when the object is moving, so it is the static friction, right? So static case, the no motion. But in dynamic case, when the object is moving, this frictional force, how can I write the friction force? So this is the friction force, right? If we go mu r, so it is mu r, so it's mu r equals mg cos theta. So it is equals to mg cos theta. So this is the kinetic friction. When the object is moving, that becomes mg cos theta. Here, that means until the object start the motion, the frictional force changes with the angle as a sine function, sine curve. And after it start the motion, so frictional force changes with the angle as a cosine function. So then you can draw the graph. This is increasing as a sine function and it's decrease as a cos function when the inclination increases. So how can draw? This is given to think that maximum angle should be 90 degrees because in the incline we cannot increase the inclination more than 9. So this is the sine theta. I'll remind you that's how the sine theta and cos theta. So sine theta goes to like cos theta is starting from up and then going down. So here it is 90 degrees. Here this is 90. So this is decreases with the theta. This is increases with the theta. So we don't need to go into it, but our frictional force is just like a sine curve until some value when it start the motion. But 90 before 90 degrees, it start the motion. 60. This is a friction. So it's the frictional force will be maximum when theta is start the motion at such a value. Let's say it is sine inverse 3/4, something like that. Then after it start the motion, what happens? Because the mu increase, mu added to there, so then the frictional force it will suddenly decrease, and then just rapidly drop here, and then it changes as a cos function. This is the 90 degree. So this is the friction graph. How the friction force changes in the theta when you change the inclination. This is you can see here, right? This time that the friction force proportional to cos theta. That's how this graph and this part is friction force proportional sine. So sine curve and cos curve. By combining this, we can get it. Okay, is it clear then? Yeah, right. Then copy down and let me know. Right. All right. Okay, we'll discuss now. We'll send you the tutorial and discuss more question later. Then, first, then we got more the new topic. All right. So, the equilibrium of forces. We go to the equilibrium. Let's. Oh. Only rest. It's useful. So here then do in let's say if the friction is not finished actually. Why I'm saying so is if we go into next part that is work energy power also the friction will come. You can't forget about this whole thing because if those things come with the future lessons also, right? Then day by day more theory parts are added. So you have to forget about the previous thing. Always you need to keep those mind. With all the things you need to keep in mind when you are going to discuss that write the answers for the problem related to the work energy power. Also, you need to know about this all. As combined with the link with the friction, the motion, and everything will come. So don't forget them, right? So that's why I'm saying so. That's this any lesson is not finished, right? So we move to the new theory. We are going to add some new theory. Now to finish this, adding some new theories, right? Always you are doing like that. We adding every day. We adding new parts. If you have any doubts up to this point, then it's better you will need to go through it and then get a better understanding. Because the physical class I will discuss more question related to things. I have to like given the tutorial also some different type of questions also we discussed. Little different type. The physical one, different types. Main thing you need to keep those mind. Okay, look at the understanding of let's see this there's a ball, right? If you place the object there by applying a force on it, let's say the 100 Newton. Weight of this block, let's say 50, 5 kilograms. 5 kilograms. Block is find the friction applied on the block. Right? Find the friction line on the block. ഇതിന് കോഫിയുടെ friction find the coefficient of friction. Find the coefficient of friction between the block and the surface. Between the block and the surface, as the block is just as the block is just sliding over the vertical wall. Sliding over the vertical wall. Clear? Even then, after I can phone you. I can apply for sand in place. Now it's just about to slide down, right? So now what is one should be the friction between. If that friction is not sufficient, we know that the block will go down. Cut to practical one. So you have to be able the body is moving. If you have a small or block, they stick with you. If you stop the vehicle moving, then this will drop down. So then you can you find that if the mass of the limb. So what should be the acceleration of the vehicle to keep this block stick with the wall? Right? If you take a right in what is acceleration, which is to keep the block stick with the weight, right? So the origin of friction is here you need to find the mu. To find the mu, if the block will not slide down. එකත් හදලා ඉපස්සේ අර ඔය වගේ එකක් Right. Right. Like here, what is the picture? How can I continue to manage this? No. ഇതിനകത്ത് തന്നെ ഞാൻ ബാൻഡ് ഒത്തിരി ഹലോ can ban it. Not. Normal reactions. And then it's trying to slide down, so then the friction apply. If it is not sliding down, so you can say in R should be equal to 100 Newton. So the horizontal forces should be, then the vertical forces considered, it should be equal to this 50 Newton because the weight of the in the coefficient of friction should be R 50 divided by 1000, 100 divided by 5. Here, same thing here. Different. 80, and then frictional force applied is 8. In the normal reactions is there. Right? Due to this normal reaction, that's all that is the force applied on these blocks to keep it remain the motion. Right? If it motion, you can write as a manipulation may. So this direction will be R equals to mass into the acceleration. And upward direction, there is no more than upward or downward, so it should be equal to weight. We know that it's already equal to mu R. Then this mu given R equal to MV, and that equal to MC. And the mass cancel, so the acceleration should be G divided by mu. So we want to maintain the G divided by mu acceleration to keep the block stick with this body. If that acceleration is reduced or less than this value, what happens? In the block will slide down. So it is dropped. Harder. Hi. ഞാൻ പറഞ്ഞ ആരണേ ഓക്കെ equilibrium of forces. Equilibrium of forces. What is equilibrium? If a body, again, consider about it as a body or any system which has no translational acceleration or any angular acceleration, any acceleration, angular acceleration. That means there's no any resultant force acted on it because according to Newton's second law, that should be the resultant force to make an acceleration. If there is no acceleration, means no resultant. And if there is no any resultant torque means that's a moment, then there is no angular acceleration. So if a system which has no linear rotational acceleration, we can call that body is equal. Right? That's equilibrium system. There is no any acceleration, any kind of acceleration is not there. That the angular acceleration of transition, linear acceleration is not there. That's a body they call, we can call an equilibrium. If you consider what's a body that here, some place this marker on my hand, you can see there's no acceleration. No any acceleration, right? No rotation or translation. So then, but due to the gravity, so all the objects you place in the gravity, that's the weight of the block. So if there's a weight is there, so only the weight is acted on it, what that should happen then? It should be moved down, right? Drop down, right? So it is moving down, right? When there's no, but if I place it there, so normal reaction acts on it, which equals its weight. Right? That's why, that's how this is in equilibrium, right? So that means in a gravity, all the bodies in gravity, at least two force acted on those bodies. One weight and other will be another force which balance the weight. At least two forces will be acted on it, right? All the bodies which are in equilibrium in the gravitational. So actual means that there are many number of forces and only the normal reaction. We can hold the body by applying a force in terms of the let me call that's a string. Within the tension we can apply by the string and so many forces there. So those are in equilibrium under the many different forces. Right? So let's see. One we ask us the about the equilibrium. First you write there. Some union. A force can change the state of motion. A force can change the state of motion. State of motion of body in two ways. State of motion of body in two ways. How we can make a translation of motion and also we can make a translation as well as rotation. Right? It can cause translation means the meaning translation or it can cause translation as well as rotation. Can cause translation as well as rotation. Right? However, when many forces act on a body simultaneously, many forces act on a body simultaneously, their effects can compensate. Their effect can compensate. Compensate compensate one another. Compensate one another. And we come up with the result. That there is no translation or rotational motion. That there is no translational or rotational motion. Right? Right. When this is the case, the body is said to be in equilibrium. The body is said to be in equilibrium. Okay. So that means there should not be the resultant force acted on the body to be in equilibrium. And also there should not be any moment or talk about any point to be in equilibrium. Right. Then for the equilibrium, for the equilibrium under forces. For the equilibrium under forces. Equilibrium under forces. It is clear that the main condition for it is clear that for main condition is conditions are, it is clear that the main conditions are tension are that when subjected to composition, when subjected to composition, the system composition, the system should not reduce to a single force. System should not reduce to a single force or resultant force. A single force or a resultant force. And also to a couple of forces, and also to a couple of forces or torque, couple of forces or torque. The torque, so there should not be the torque to prevent the rotation. There should not be the resultant force to prevent the motion and acceleration. Simply that means the two conditions to be satisfied for the equilibrium. One is that resultant force equal to 0. Another one is that moment or the torque about any point should be equal to 0. Then right there it says something in the condition of equilibrium. Right, condition of equilibrium. Conditions of equilibrium. Okay, then write the first one and then first one, right? First one, right? If algebraic sum of forces, acting on a body is 0, algebraic sum of forces acting on a body is 0. On a body is 0. With sum of forces acting on a body is 0. The body is said to be in translational equilibrium. Translational equilibrium. Translational equilibrium. That means that the sum of all forces sigma F B equals to C. That means there's no net force. Net force is C. Net force or resultant force. That should be equal to 0. This is the algebraic sum. That's right. Vector sum. So then it's 0. No net force. And simply you can write that no net force, right? So that's the resultant force. Then try the second. Right. If the algebraic sum of moment of forces, algebraic sum of moment of forces acting on a body about any axis or any point. Moment of forces acting on a body about any axis. About any axis is 0. Any axis is 0. The body is said to be in. The body is said to be in. Rotational equilibrium. Rotational equilibrium. Rotational equilibrium. Then when I thus for the rotational equilibrium, thus for the rotational equilibrium, the torque, limit sum of the torque will be measured in C. So it means that no torque. The net torque is the net torque. Net torque actually equals to C. The right. That would not be the torque, and that would not be the result. So both should be satisfied, and not only one. If the resultant is zero, we can't say that it's in equilibrium. In some cases, it may be in equilibrium, but not always. I will show you that how that resultant becomes zero, but it is not in equilibrium. Consider a block like this. Block like this. We apply the force, the same point. Here. Was applied to this direction, and this was applied to this. And in the same block, we apply the forces at the same points. Here is forces applied in this direction. Here force. Then apply the other. Both the cases here, net force acting on the system is zero. These two forces acted in the same line, that net torque applied on the body is also zero. And here, net force acting on the body, that's the right hand force equal to left hand one. That also net torque in this one. This reflection is perpendicular on the conjugate face. The net torque is then that force because this is the upper force multiplied by the perpendicular distance between the face. So that is not equal. So then we cannot say that net force zero is not equilibrium. Right? It may not be equilibrium like here it's a rotational equilibrium is not there. But here on the translation equilibrium, but here both rotation and translation in the equilibrium. So no rotation, no. You can draw this one, right? It's not in because there's a torque. Here the body is in complete equilibrium with not in complete equilibrium. That's a translation equilibrium only. Finish right, let me know. Right. No, static and dynamic equilibrium. There are two types. We can divide into static. That means equilibrium means there's no acceleration. But there can be a uniform motion. The uniform there's no linear constant speed. There's no acceleration. So where the object is moving the constant speed without acceleration, but all the forces acting on it is also zero. And the sum of all the forces acting on it is also zero. So we call that point of body in a dynamic. So it can be because it's moving, and then if a body is stationary, then we call it a static equilibrium. Then right there, if static equilibrium and dynamic equilibrium. In the name. Static equilibrium, dynamic. Right under this first one right here. Is the first one I write then. First one I write. If the net force is zero, net force is zero. If force the definitely is zero, and body is at rest, force is zero. We call it a zero and here, and net torque is zero. It is zero, and the body is at rest. Is at rest. Force is zero. And body is at rest, it's not moving. It is known as static equilibrium. And all right. It means zero and or net torque is zero, and the body is moving with constant velocity. It is known as dynamic equilibrium. It's known as dynamic equilibrium. Then right topic. How we consider if a different number of forces acted on the body, the equilibrium we can separately discuss with the what are the conditions to be satisfied to be in equilibrium under the different number of forces acted on a body. So when you solve in the problems, you need to also know that you need to identify what are the forces acted on it and then how many forces And then if you can, then you can check whether those the conditions are satisfied or not. If it is satisfied all the conditions, only you can apply the theories and other things accordingly, right? So let's write the conditions for the equilibrium. Conditions for the equilibrium. Of two forces. Equilibrium of two forces. In such equilibrium, the body, let's see what should happen. Those two forces acted opposite to each other along the same line of action and with the same magnitude of the force. Like this. Over here, the two forces left, the forces are free and those two forces should be acted on body length. Same magnitude, should have same line of action, there's a falling here, and they should have a same, also opposite to each other. Not the same. Direction on the opposite. Okay, then write under that. This condition, right? The first condition. The first one, right? First one, right? The two forces should be equal in magnitude. Two forces should be equal in magnitude. The second condition, right? The directions of two forces should be opposite to each other. Direction of two forces should be opposite to each other. Direction of two forces should be opposite to each other. Third condition. Two forces should be collinear. Two forces should be collinear. Right, so the line of action of two forces should be same. Same. Two forces should be collinear, right? The same point of application. Point of application of the forces are also same. And draw this under the it is under the equilibrium. Two forces. That's the thing. And if someone asks you that when this block is placed on the chamber, the weight factor is the normal reaction. Yeah. You can say normal reaction to equal the weight because the body is in equilibrium, and also the band reaction and weight should be acted at the same line. A line can I will stop the class from this point only because I thought that you were hungry. We start the class at 11, 12 in the way. But after that, thing at the mother name. But again, at the that outing of color. Under three forces, we need to do some calculations and also the many number of forces also we can. Okay, okay. Phoenix take a look. Do you have any doubts, any questions? You can ask. Can one question? දෙහිනම් අපි නම් හරි. Bye. You can leave. Just leave. Okay, you're welcome. Devani Ciara, you will. How the Devani Ciara again?
Thank you, sir.
Okay, you're welcome. You can leave then. If you have any questions, you can ask. If not, you can leave.